Now we have data, so we want to present the data. You want to present your data. So basically, we want to present data, and we want it to look nice, right? That's the first thing. We want to present data. We want to present it nicely, and this is isn't wrong. This isn't wrong, right? Not wrong at all. It's sort of true to an extent when we have a bunch of raw data, and but it isn't really any good to anyone in this raw form. Okay, when we say we present data, we mean it as that we want to provide a kind of visual or graphical summary of that data, so we can detect trends in that data. Okay, so uh, let's say that let's try to interpret this raw data. Okay, in this data, just so we can use it as we move along. This is kind of like hypothetical data. I just make a this is just a makeup, right, data. So basically, this is a way of 100 female students in my class. So I have 100 students. I weigh them, and then this is the data that I have. Note that this is only a makeup data, then but doesn't represent anything. Okay, this is very important. Just want to make sure that. Okay, next we are going to organize this 100 data uh, into a presentable form. One that always used for this kind of data is what we call as a frequency distribution. Okay, frequency distribution. First thing that you want to decide when you can start the frequency distribution is the number of classes that you want. The number of classes on your frequency distribution, and to kind of get there, we first look at the range, and then we kind of think about the amount of data that we have and how big these classes to be and what they are classes with. Is so we'll can go through that. So we will try to go through this process now. Okay, so let's find the range. So what means the range is the difference between the highest data value and the smallest data value. You can have this raw data. Okay, you can have this raw data, and then after that what you can do is look at these data. You can look at this data, you can sort them from highest to lowest. Okay, you can sort them, you can whatever you can do, and then you look at the highest and also at the lowest. Okay, so from here you can see that in our value, the highest value is 80 kilogram and the lowest value is 23 kilogram. Wait, who weigh 23 kilogram? Okay, so again, this is just a makeup data. So the range is 80 minus 23 will become the 57. This is our range. Okay, this is our range. So as we think about how many classes that we want to keep in mind that we don't want to spread them out too much and have, like 50 classes, like 50 classes for a range of 57. That will become a silly day. That will be much information in the data. In each class, maybe just one. So one or two pieces of data, but we also don't want to get it too small. So we don't want three classes and then they get all collected into these three classes, and we don't see the significant shape of the data either. So rule of thumb that we always use is the number of class between 5 and 15. This is just a rule of thumb. So it depends on what kind of data, what kind of information and what kind of data that you have, and depends on your study also. So there is what we call as Sturge's law. Okay, this Sturge's law is one way to calculate the number of classes if you find difficulties to determine the class yourself. Okay, so you don't how many classes that you want. You want to have 5, 6, 7. So you can use this Sturge's law. This law has been used for many statistical packages to build a histogram. Any statistical packages out there, they have they basically sometimes most of the time they use this Sturge's law. So n here, what we call as n here, is the number of observation or sample size, which is in this case is 100. So you can use this log n, log 10 for 100 is 2. So the number of classes that we will use here is 1 plus 3.3 times 2 will be 7.6. Okay, and then the 7.6, when we round it up to and become 8, just to note that Sturge's law has some limitation. Okay, so this is just what we can. So you will have 8 classes, 8 classes, and from this Sturge's law. Okay, so we'll have 8 classes, and we draw it here. So the next thing you want to do is the class width. So you have the class, and then you have developed the classes, and you have how big, how wide is the class. So you have these classes, and then the next thing you want to do is to find the class width. So here you have the range is already, you get the range here. You get the range is 57, and then you get the class is 8, just we calculated before. So the class width is the range divided by class width. Okay, so the class width will be 57.8 equals to 7.125. So, and for class width, we've had a ceiling function on this, and the ceiling means to round up the value to the nearest whole number. We cannot put decimal points over there. This is for, to have the width, and then just round it up. So the nearest number. Always round it up. So even if this was 7.01, we still round it up to 7. So in this case, 7.15 is closer to 7. So go to the nearest round number. So our class limit always start with our smallest data value. So our smallest data value is 23, right? So here it will be 23. So our class width is 7. And so the difference between 23 and our class limit should be 7. So 23 plus 7 will be 30. So that's going to be end of the class limit. So then we can continue 31 plus 7, 38, 39 plus 7, 46, 47, so on and so on and so forth. And remember that we have the class, how many classes that we have that we calculate by Sturge's law? We have 8. So we have 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 classes here. So now we have this already the range, the classes here, and then also the range of weight here from 23 to 43. Now we want to look at the tally and to calculate the to determine, sorry, not to calculate, to determine the frequency. So taking this raw data, so again this raw data here, and arranging it into this frequency distribution, and I think the best way to do this is just to start right here with your first data value and hitting a tally where it lands. So 46, of course. Okay, let me change this one. So let's say this is 46 here. Okay, and of course it's going to be right here. Where is 46? So this is 46, right? And then after that you're gonna put a tally here. Then we move on to 51. 51 will be here, put a tally here, and so on and so forth. We'll just keep doing it. 31, 31 will be here, put a tally until you get all the tallies, right? This is the tally, and then after 4 and then you get 5, you just cross. So you just do this for all other for all other numbers, and then you get a crossover. So this is something that you need to do. You do tally. When you hit the 5th tally, for example, here you cross like this, indicated it reached 5. So I hope by now you know how to do the tally. Okay, this is something that is well known. I hope so. Okay. All right. So I just tallied up the data. Hope it's right. Got it into the frequency distribution tallies here, and now I can count up my tallies and record my frequencies. So here I have 1, 2. So I have 2. So this is 5, right? This is 5, 10, 12. So this is 12. So you can calculate so on and so forth. This one is 1, 2, 3, 4, 5, 6. 6 times 5 is 30. So this will be 31. So you can do this by yourself, and then try and then try to look at what you get. So here I already calculated. I hope you said right. If I'm wrong in the class, you just let me know. Okay, you have 2, 12, 27, 31. So this will be the frequency. So this is the frequency. So yeah, I should have my pad here. Okay, this is a frequency. It's a 2, 12, 12. So this is, so which means that the only two students, there are two students have weight between 23 and 30, and then they have 31 students have weight between 47 to 54. So this what this means by the frequency. So what's next? So what's next? So from the frequency table, from the frequency table where you have the range of weight and also number of sampling here, okay, so from here you can create the histogram, what it means, one of the way to represent your data for frequency distribution. Remember, and this is very 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 important, make sure that you always have the axis. Okay, the axis title here for both x and y axis. Sometimes you don't want to use the range or class, yeah, that's way 23 to 3 to represent the x axis. So another way to do this is by using what we call as the midpoint. The class midpoint can be calculated like using this formula, which means that the lower boundary 23 uh, plus the upper boundary, which is a 30. So 23 plus 30 divided by 2. So you can get the midpoint. Okay, like here. So you can get 26.5 for this range. Okay, 23 to 30, the midpoint will be 26.5, 31.38 is 35, 34.5, so on and so forth. So this is the height, the midpoint. So and you get the histogram at midpoint. So this is similar to this histogram. Okay, the only difference is the uh, the midpoint here, the x label. Okay, and then another type of graph that can be drawn to represent the same set of data as a histogram represent is what is called as frequency polygon. A frequency polygon is a graph constructed by using lines to join the midpoints of each interval or beam. So the heights of the points represent the frequencies. As I mentioned before, the midpoint is calculated by adding the upper and lower boundary values to the beam and dividing the sum by 2. So you can get this all these values. Okay. So, or you can present it as a pie chart, a donut, or whatever presentations that you feel nice and representative of your data. You can explore this from Microsoft Excel, or you can explore your Excel with your data to create your own style of presentation. Okay, you can go to insert, you can use uh, select chart, and then you can change chart or whatever. So this will be another task for you, but I will not cover this in this section or this lecture, but you can explore it. Okay, good luck.